We'll start it in 5 minutes. Okay, so today we'll be saying with 9 questions, and then we will be doing some things in QGIS, and then if time is there, we will go for Google Extension. So these are the things we'll be doing today. In QGIS, very basic things like making map, clipping, those things. Okay, so we'll start now. First, we take 9 questions. So this is the first question. First, you try to find, then I will. Okay, okay, take some time. Okay, so now I will explain. So if you see, first question is regarding bore side direction. So bore side direction is actually uh, direction in the gain of antenna. Here it is written perpendicular. So statement is false. First statement, because not perpendicular, it will be in direction of gain of antenna. Okay. So second question, if you remember, that is true. Like antenna gain formula is this only, J equal to 4 pi by lambda square into physical area of antenna. We have done one question also previously on this, physical area of antenna and antenna efficiency. So this statement is true. Then third statement, for imaging the data that required a relatively large area, phased array antenna are commonly preferred. So this is also a true statement. And the transmitter and receiver can be in different location in case of monostatic antenna. So not monostatic antenna means monostatic antenna, transmitter and receiver will be at same place. Bistatic, if we tell, then it can be, there can be comparable distance, means there can be distance between uh, transmitter and receiver. Monostatic, there is no difference, means both has to be same. So this is also incorrect. So true is, in question it is asked true statements. So two and third. second and third. So B option is correct. Note down. Then we will go for next question. Okay, so now we'll go to next question. So correct arrangement of electromagnetic radiation according to their frequency. So first you try, then I will tell the answer. Okay, so let us suppose first gamma x UV, IR, microwave, radio. So this is increasing wavelength and this is increasing frequency. So answer will be C. If anyone also you remember, you can go because wavelength is indirectly proportional to frequency. So it will have inverse orders. Okay, now let's go to next question. So take some time, then I will explain. Okay, so question is Doppler weather radar measures precipitation as. So there are three options: space integral at a given instance, time integral at given at a particular location, space and time integral. So if you see Doppler weather radar emits and it can be only at means it is only going through space. So what it gives is a space integral at a given instance. So third answer will be A. Okay, so now we'll go to next question. This was on TRMM precipitation radar operates in dashband. So try to recall, then I will tell. Okay, so as this is just a theoretical question, answer will be given. You would have read in theory. So we'll go to next question. Okay, so first question is match the following, and uh, you you can solve. Then I will solve next. So first first is false alarm ratio. This is also called a probability of false detection. So as this suggests, probability of false detection means false will come, and if you can see only one option is there with false. So F by H by H plus F. So first option will be C. Second is misread. So if you see, miss is denoted by M, and here this okay, if so otherwise if you remember definition, or you can directly write, if it is not hit, like um, 1 minus hit will give you, this is probability, so 1 minus hit will be miss. So if we go, second option will be D. Then we have critical success index. So this is also called as threat score. I will explain. So this is equal to total number of correct event forecast. That is total number of correct event, total number of correct event. So here that will be represented as H, and what is total number of forecast plus misses. So total number of forecast is H plus F, and miss M. So answer will be H by H plus M plus F. And probability of detection. So here only hit and miss will come, false we will remove. Okay, so note down this, then we will. Okay, so now we'll go to next question. So, which of the following is an example of biological echo? Just a theoretical question. So, just a second, then I will explain. Okay, so when radar emits signals, it sometimes birds interact with that. So that is mm, a noise or echoes reflected from birds speaking. So that is a biological. Okay, so we'll go for next question. Noise in Doppler weather radar data produced by unusual rates of refraction in the atmosphere is referred to as. This is also a theoretical question. Just take a few seconds and I. Okay, so that is termed as anomalous propagation. Okay, so the question is choose the statement which is not true regarding radar from the following. Okay, so this Doppler weather radar are active microwave radar sense active microwave sensor. So this is a true statement. PyArt is an open source software package for working with radar data in Python. This would have been explained in your tutorial. So this is also true statement. Range is estimated using time taken between transmission and reception of a signal at radar station. So this is also a true statement. If you remember, R equal to C into tau by 2. So tau is time of when it goes from source to receiver and back. So this is total time. This time. So this next rad is a network of 160 high resolution C band Doppler weather radars. So here it is not C band, it is S band. So that was so this is not correct. So this will be the answer. Okay, so we'll go for next question. Well, so Dash is a free platform independent software distributed from NOAA's National Center for Environmental Information that allows the visualization and data export of weather and climate data. So, if you remember, this is direct question. NOAA's Weather and Climate Toolkit. This is Python question, and here in one before question we asked about PyR tool, if you remember. So that dash is used to read a radar file using PyR module. So that command is pyr dot io dot read. So this will be the option. Okay, so for weak questions, that's all. Now we'll do something in QGIS. So if you any of you have, just open it. Take 5 minutes. Then we will start with clipping. Okay, so you also open your QGIS. Okay, so any so till now we were in Google Earth Engine, we were learning how to export our data. Like we were calculating something like NDWI, and we were exporting it in our drive. And suppose you have download from drive, and now you have a TIFF file of suppose whole India, and now you want to analyze only for a specific state. So how you can first you can download shape files. I will tell. So for downloading shape files, 1 minute, I have to share the screen. So for downloading shape files, you just have to search for Diva GIS, and when it will open, you go for free spatial data and country level data, and here you search whichever uh, country you want. So here I am selecting India and administrative area. You can have this also, inland water, road, railroad, these all are also there. So here administrative area, and then click on download. So from this only I have done, and I have, suppose after that you will get whole India shape file. So here I am just showing you for some state shape file we have, like this 5 states. And suppose I want Maharashtra to analyze some raster data only for Maharashtra. Then what we can do is first here Maharashtra we have to take from this zip file. So for that we will go to open attribute table, and here you can see this is the Maharashtra file. So first select that and click on
Jayapura. Matanpura. Matanpura.
okay. So as I was telling, first go in open attribute table. If you have to cut for Maharashtra, then just select Maharashtra. Here it is, and then click on editing button. So as you can see, this is selected. Though, then click on inversion. So this will be selected. All other states will be selected. Then as you have to take Maharashtra, so other you have to delete. So click on delete. Delete 4 features. So now only we are left with Maharashtra. So in previous classes, I have told you from Google Earth Engine how to means save it in Drive. So or any other file, any TIFF file which you have and you want to analyze only for your uh, means your state or any other state, then you click, and then here I will open one data like this is elevation data. So uh, from here I have to click. So like this, any TIFF file you can have and any particular region you have. So that region is your vector file, and other is your suppose raster file. So what you want to only obtain that for Maharashtra here. So what we'll do, raster extraction, clip raster by mask layer. So here mask layer we will give us that Maharashtra file, which is our IND ADM1. and this is your raster file. So then when we'll click on run, if we remove this whole data, then you will be able to see this is that data has been clipped for that region alone. So suppose like in previous classes we were finding for NDWI, one reason we were giving. So suppose as India we were giving as reason, and now you want only for Maharashtra. So you can do it like this. And next I will show you how to make map from here. So after doing this, you can go in project and then click on new print layout. And here suppose I am giving name as map. So it will open like this. Then you have to go to add item and add map, and you here draw like this. So this has come. Now you can, if you want to zoom out or move something, then you select this fourth item, which is here. If you will see this one, move item content. So with this you can move this your raster file, or you can also zoom out, zoom in, anything, whichever you prefer. So suppose we have kept here. Now what we want to do is we have to go in grids, and you click on add a new grid. Then go in grid 1 and click on modify grid. Here in interval, means this I am use map CRS, and grid type is solid. Solid means this line will, this grids will come as solid lines. And here I have defined like use interval is map unit. So at one unit draw this. Okay, so in X I have done, and now you can do in Y. So these are the grids which have came. You can make it, suppose this grids are looking more to you, so increase spacing according to your convenience. And this lines which are very bold, now you can change that also, like line style you can go. And this is very thick, then you just width you make it less, like so. Now it is okay. Do this here, I will. Okay, so after this, with you have suppose made it according to your convenience. Now you can see it is in very slight line stroke is there. If you want less than this, decrease or increase according to your convenience. And you can make it dashed line also. For that you have to go here, dashed, so it will come like this. And then we have to, so we have gone till here. And suppose you want this frame, then take it like this. Here, zebra, if you define frame size, you can reduce or increase according to your convenience, and frame line thickness also. And if you want different color, just choose that. So we'll keep black itself here. Now draw coordinates. So here, if you can see, now coordinates has came. So if you want only degree, then means degree minute also, if you want, just make it degree minute aligned. Okay, or if you want degree minute second also, that also you can do. And precision, it is showing, means like three zeros are coming, so precision you can remove. So now it will come like this. And this maybe if you don't, as okay, I will zoom. So if you see here, it is here also, means in left side also, right side also, according to your convenience. Like here, if you see left show all, right show all, everywhere it is written. So we can keep only two sides, like lat long we will be able to see either from top left or top bottom, any one you can keep, or left and right any one you can keep. So we will keep bottom and left. So right we are disabling, so you can see it has gone, and we are disabling top also. So now you see only bottom and left it is there. And if you want to, if you don't want outside of frame, then you can shift this. Now it has came inside of frame, but it will be difficult to read if you keep this lines also. So for now we'll keep outside only. And after doing this, we can save our lay, means this map, export as image. You can give map also, means PDF also. So I will show you both how. So here DPI you can define. So first, for now I am taking 600. Okay. So our, it is saved. I will show you that file. So you see map, it has came like this. Here coordinates are there. This you have to bring it inside because our defined space was still here only. So if you want, I so what we have to do. So now everything is there. So again we can say play layout, export as image. So now if you will see, it would have come correct. So this is the uh, so we can save this as PDF also. So you can see this. Okay. So this is how it comes, and many things you can adjust. Like if you want north arrow, then that will be there. Add a scale bar will be there. So see, add north arrow. So where you will draw. This is north arrow you got. Then add item, add a scale bar. So this scale you have got. So like this, many things are there to add here, and whatever you want, it can be done. Like however map you want, you will be able to do it. So that is what I wanted to do in QGIS. Now you can open your Google Earth engine. One a small code we will write there, and then we can close the session. So you open your Google Earth, then we can start. Okay, Google Search engine is currently not opening. It is having some problem. So we will keep this session till here only. What I wanted to teach, I will show you in next session. Huh? Hello? Okay, so you can do.